6.6. Objective. Use proportions with scale drawings. Okay, for the vocabulary, you need to know scale drawing, which is just a two-dimensional drawing that is similar to the object it represents. And a scale model is just a three-dimensional model that is similar to the object it represents. And number 3, the scale, which just shows the relationship between the drawing or model's dimension and the actual dimensions. For example, in this picture in the first word problem, the scale would just be 1 centimeter to 200 meters. So 1 centimeter would just be the drawing or the model's dimension, and the 200 meter would be the actual dimension. Okay, to learn the objective of this lesson, you really just have to do a lot of word problems. So we're just going to jump straight into word problems. Part 1 says, use a scale drawing to find the actual distance. Okay, so let's look at this word problem. Teotihuacan. On the map, the center of the pyramid of the sun, so it's right here, is 4 centimeters from the center of the pyramid of the moon. So from this point to this point, it's 4 centimeters on the map. But this is not the real distance. We have to find the real distance or the actual distance. How do we do that? So that's what the question asks here. What is the actual distance from the center of the pyramid of the sun to the center of the pyramid of the moon? We again need to set up a proportion by using the scale given on the map. So 1 centimeter on the map to 200 meters in reality, okay? I will set this scale, or in other words, the ratio, equal to 4 centimeters to the actual distance, x, okay? X here is, I'm going to write meters, because the actual distance is measured in meters, okay? And then now we can cross multiply, because there's nothing to simplify, okay? We'll cross multiply. And we can cancel out our units, because we don't really need them in our calculation. X would just be equal to 800 meter. Finding the scale of a drawing. Okay, for this problem we need to find something like this, okay? So let's read. Floral carpet. Every few years, the Grand Place in Brussels, Belgium is decorated with a large floral carpet made of begonias. Before making the carpet, designers make detailed scale drawings. Okay, so scale drawings are just two-dimensional drawings, okay? Suppose the floor carpet is to be 40 meters wide in reality, meaning the actual distance, width, okay? And a designer then creates a scale drawing of the carpet that is 20 centimeters wide. So on the drawing, the width would be 20 cm wide. But in reality, or the actual width would be 40 meters wide. Okay? And then here it asks you to find the drawing's scale. So we need to simplify here. 1 centimeter to 2 meters will be your drawing's scale. Finding a dimension of a scale model. Okay, so it's a space shuttle. A model of a space shuttle has a scale of 1 to 52. So I'm going to bring in a picture of a space shuttle. Okay, so here I brought in a picture of a model space shuttle, and it has a scale of 1 to 52. The space shuttle, okay, the actual wingspan of a space shuttle is 78 feet, according to this word problem, and we need to find the model's wingspan, okay? So what is the model's wingspan? This will be considered the wingspan. So in order to find the model's wingspan, and let's let it be x, we need to set up a proportion. Okay, 1 to 52. Okay, so I know this would be the 1 would indicate the model, 52 would indicate the actual length. Then in the numerator here, I should put x. Okay, and 78 is the actual length of the wingspan. Okay, and then now I can simplify. Okay, so we can divide 52 by 2 to get 26. Okay, and then 78 divided by 2 to get 39. Okay, so we cannot simplify anymore, so we need to do our cross product. 26 times x is 26x. 1 times 39 is 39. And 39 divided by 26 would just be 1.5. And we need to label feet. Would be the model's wingspan. X would equal to 1.5. So 1.5 feet. Okay, let's do another word problem. The length of a space shuttle is 122 feet, so that would be the actual distance or the actual length. And now your question wants you to find the length of the scale model to the nearest tenths of a foot. So we have to round that to the nearest tenths, okay? Meaning one number after the decimal point. Okay, so I know that my scale of this model from the first part of my word problem is 1 to 52. So again, I will use 1 to 52. Okay, and then I will need to set that equal to x over 122 feet. The reason why x is in the numerator is because that's what I'm looking for. I'm looking for the length of the scale model, okay? And 1, the numerator, represents the scale of the model. And 52 would be the actual length, okay? So we can simplify here. 52 divided by 2 will be 27. 122 divided by 2 will be 61. Okay, and then that's all we can do. So we need to do cross multiply. 27x, which is equal to 61. And then 61 divided by 27 will be, so it will be about 2.3 feet. Okay, to write the scale without units, you need to use the conversion factor. Okay, let's say 1 inch to 10 yards. I need to change it so that I can get rid of inches and yards. Okay, so look, 1 inch to 10 yards. I'm going to multiply that by 1 yards to 36 inches. This is the conversion factor, okay? Conversion factor. Therefore, I can cancel out yards with yards and inches with inches. And then I multiply 1 times 1 is 1. 10 times 36 is 360. So 1 to 360 would be my scale. Okay, then here you see I don't have to write my scale with units. And the same thing would go for this problem. 1 inches to 20 feet. I just have to multiply that by 1 feet over 12 inches. The reason why I would write 1 feet over 12 inches and not 12 inches over 1 feet is because I want to cancel out my units so that I don't have to write my scale with units. So the final answer would be just 1 over 240, or simply 1 to 240. And that's it.